graph is going to come to us in pieces, and we're going to have to graph each one. We're also going to need to give the domain and range in set builder notation. So that's our other thing. It says to analyze key factors, but to me the key factors are the domain and range, so that's what I want you to give me. So again, you're going to graph, and then you're going to give me domain and range. I'm going to use some different colors so that this is color coded and kind of hopefully makes a little bit more sense. If you would like to use some different colors with me, please do. Here we go. I'm going to start with my first one, and I'm going to make this part of my graph a baby blue. Pick any color you want, and again, if you don't want to color code, you don't have to. This is not a must. This is a do whatever works best for you. Alright, so this is telling me to graph 3. So think about 3 for a second. Y equals 3 is what? If I said graph y equals 3, what would you do? Straight line. What type of straight line? Horizontal. And it lives where? At 3. Okay. So horizontal line that lives at 3. So that means all day long my y values are 3. Do we agree with that? Yes, no? Okay. So all day long my y values are 3. Now, this graph says in particular I can't graph it everywhere. It's going to give me a specific location where I'm allowed to graph it. I'm only allowed to graph it for x values smaller than 1. Now, I know it says smaller than 1, but I'm going to start at 1. And we'll talk about what we're going to do there in a minute. Then give me a number smaller than 1. Negative 1. What else? 0. Okay. So those are going to be the numbers that I plug in. So again, this graph lives at 3. It's a horizontal line at 3. But my x values start at 1 and get smaller. Okay. I'm going to graph this first point. And when you have a point that's not truly a part of the graph, you draw it as an open circle. Meaning, do you see how it says it has to stay less than 1? So this point isn't a part of the graph, but everything I draw this way will be. That's what an open circle represents when we're graphing. I have a point at 0, 3, and I have a point at negative 1, 3. And can you kind of see the pattern and what's going to happen next? What's the next point going to be? Negative 2 and 3, negative 3 and 3. It's going to continue this way, and that is where it's allowed to live according to this if statement. So I'm graphing the line, the horizontal line at 3, but it can only live to the left, and this should be connected too. It can only live to the left of 1. Alright, next part. Alright, this part of my graph lives in between 1 and 4. Okay. 1 and 4 is where this one lives in between. And again, we lay 3 points on each part, so I'm going to just pick a number in between. You can pick any number you want. I'll pick 2. You can pick 3. You can pick 3.5. Any number as long as it lives in between 1 and 4. And we're going to plug them in. Do you see how this one has a spot where I can plug in? Okay, so I'm going to plug in. 2 times 1. 2 times 2. 2 times 4. Okay. So this next part of my line goes from 1 to 4. Now, remember I made an open circle because there was no equal to. Here I have equal to, so these are going to be closed circles. So I have a closed circle at 1, 2. I have another point at over 2 up 4. I have another point at over 4 up 8. So this is another piece of my graph. So piecewise function, meaning that it's coming to us in pieces. And then I'm gonna go one more color. Because it's only giving us a specific spot. So you can think of it, it makes me think of like when you get on a plane, you know how planes aren't allowed to fly in certain areas? Yeah. Or they have their flight pattern and so this is where they're allowed to be. So it's telling me this is where this graph is allowed to be. The rest of it is a no-fly zone. So for the purple graph, it can live here to here, but the rest is a no-fly zone. So it's only allowed to live in between 1 and 4. It's only allowed to live smaller than 1. This one's only allowed to live bigger than 4.
Okay, so like the blue one had like 1 end and then the purple one had like 2 ends.
Yeah, so this one is going on forever because it didn't have a spot where it stopped.
Okay.
It's just less than. Yeah. You don't have dotted lines for this. These are open and closed circles depending on if there's an equal to. Okay, so let's graph the peach part. You guys are asking good questions, so keep on thinking, keep on asking. Okay, so this is saying graph bigger than 4. So I'm still gonna start at 4, but then I'm gonna think a number's bigger, so I'm gonna pick 5 and 6 because, well, they're bigger. Do you see, like this first part, there wasn't a spot for me to plug in? Is there a spot for me to plug in values for x? No. So it's just gonna be 6 all day long because this is a horizontal line at 6. So I have a point at 4, 6, over 4, up 6, and it's an open circle. So this one is an open circle again because it can't be equal to 4, so it can't truly live here, but it can live everywhere to the right of here. So again, I'm almost thinking about this like I said, airline flights and where they're allowed to be, right? Do we remember last year when we had that kind of crazy situation where they had planes in the same area a couple times and like they were almost overlapping flight paths? That was bad. Right, so we don't want overlapping flight paths here either. So this one can only live here. This one can only live here. They don't overlap with each other. Alright, domain and range in set builder notation. Here we go. So again, all day is going to be set builder, so you're not going to switch back and forth. We're going to stay in the same notation all day. The domain is a compilation of all the pieces of the graph. Do you see how everything is covered if we scan from left to right? Because even if I have an open circle, I have a closed circle below it to fill it in. So everything is covered, left to right. So x exists in the set of real numbers. It is all the things. For the range, where does my graph start? What's the lowest number?
2.
What's the highest number you can see that it can get up to? 8. So all of my graph lives in between 2 and 8. So my entire graph exists between these two numbers. There's no graph outside of those numbers. So again, it's a compilation of all the things. What's the highest point and lowest point that you see? When you're ready, you can flip. The next one's a little bit easier because it only has 2 parts instead of 3. Another thing that's kind of important to note is that if you have 3 equations, you have 2 open circles. So the number of open circles is always 1 less than the number of equations you have. Alright, let's flip. So I'm going to do 2 different colors for this one as well. Bless you. Bless you. Alright, here's x and y. Do you see how it says that my x values have to be less than or equal to -2? So I'm going to start at -2 and then I'm going to pick numbers less than that. So I'm going to pick -3 and -4. Do you see how there's a spot I can plug them in? Okay, so let's do that. Negative 2 plus 1. Negative 3 plus 1. Negative 4 plus 1. So I have a closed circle. Anytime you have an equal, it's a closed circle. So this one is going to be my open circle. So I have a closed circle at negative 2, negative 1. I have another point at negative 3, negative 2. And then negative 4, negative 3. Can you see the pattern? So I could continue making points, right? Like we can see what's happening. So I'm going to draw this way because it's going to continue forever because I can pick anything that's smaller than or equal to negative 2. Right, now I'm going to go to the other piece. This one says pick stuff bigger than negative 2. I know it says bigger, but I'm still going to start with negative 2 and go from there. So what's a number that's bigger than negative 2? Negative 1. What else? 0. Perfect. And we can plug those in because there's an X. There's a spot to plug them in. Negative 2 is really what?
Positive 2.
Yeah. Negative 1? 1. And then negative 0, that's not really a thing. So 0. Again, it's starting at an open circle because it can't be at negative 2, but it can be anything bigger than that. So I'm going to go to negative 2, positive 2, and I've got an open circle. Then I'm at negative 1, positive 1, 0, 0, and we could follow that pattern, right? Like I can see what's happening, and it continues off. Oops, and that actually went through my points. Make the points bigger. Continues off this way forever. So again, we're going to think about domain and range. So whenever it asks you to analyze, I'm asking you to look at domain and range. So where can your graph live? So X such that, and remember your range is Y such that. Alright, think about X first. If I scan from left to right, is there any spot where the graph doesn't live? No. And even though there's an open circle in one spot, there's a closed circle below it that covers it up. So X such that X exists in the set of reals. Now I would say 99.9% of the time your domain is going to be that. It's going to be all reals. So if that makes you feel better, that would be my go-to if you're not sure for the domain. For the range, what's the highest my graph can go? 2. Does it actually touch 2? No. So this is going to be Y less than 2 for my range. Because it really can't live at 2, but it can be anything less than that. Now, sometimes the pieces of the graphs connect. So you have this open circle, and then the closed circle fills it in. So that can happen. If an open circle and a closed circle overlap the key value, the circle is closed overall. So the circle is closed, it exists at that point. I feel like normally we look at sorted problems and we're like, well, this is going to be bad. I think these are easier because they're not going to ask you to graph. They're just going to ask you to write an equation and evaluate. So I think these are actually easier than what we were just doing. Alright, we have Tony, and he is crafting, and he is buying ribbons for his crafting. He will pay $8 per roll of ribbon if he buys 4 or fewer rolls. I'm going to color code again on this one. He's going to pay only $6 per roll if he buys 5 to 10. And then he's going to pay 4 if he purchases more than 10. So we want to take all that and we want to translate it into a piecewise function. Alright, $8 per roll. So if I buy 1 roll, how much do I spend? 8. If I buy 2 rolls? 16. So we're taking 8 and we're multiplying it by the number of rolls. Now, what window does it have to live in though? So if what? How many rolls can I buy at that price before it switches on me? 4. 4 or fewer. Now, beyond that, let's think about what makes sense. Can we buy negative rolls of ribbon?
No.
Can we go to the ribbon store and see the ribbon and decide it is not up to our standards and buy 0 rolls?
Yep.
Yes. So we can say bigger than or equal to 0, but also smaller than or equal to 4. Alright, next. 6 rolls of ribbon, or sorry, $6. $6 per roll. If, what does X live in between here? So it's less than or equal to what? 10. Greater than or equal to 5. And then we're going to take this last part and put it in very literally. So 4 per roll if, what do we have there?
10 or more.
If it is greater than 10. So I'm going to just write it very literally based off of what I see. Alright, 3 rolls of ribbon. What window would that fit into? The purple, the peach, or the blue? Purple. So this purple window, 3 fits in here. If I actually plug it in and I buy 3 rolls of ribbon, how much am I going to pay? $24. Oops, and then I wrote 25 for some reason. Don't know. Got nothing. Okay, next one. What if I buy 6 rolls? How much would that cost?
$36.
Okay, how did you know?
6 times 6.
6 times 6. So you're fitting it into that peach region. Oh, yeah, move it up. I sure can. I just realized how low that was. Okay, so that type of problem, like I said, I think is a little bit easier because you're just kind of translating it as opposed to graphing it. Alright, this last little bit that we're going to talk about is what if you have an absolute value graph. So absolute value graphs fit into this section because you can think of them as having 2 pieces. A piece here for the negative numbers of x, and then a piece this way for the positives. So we can think of this as being 1 piece, 2 pieces. So that's how we can fit this into this section. So y equals the absolute value of x is my basic equation. But if I wanted to write it as a piecewise function, I could say that it's let's start with negative. Negative x if x is less than 0, and x if x is greater than 0. Alright, so that's how this fits into this category of being piecewise. So let's flip and we're going to graph a couple like this that end up as a V shape. Alright, let's start with the fact that our parent function, have you heard the word parent function before?
Yes.
Okay. The parent function is the most simplified, honed down, easy version of the function there is. So the parent function is just x with the absolute values around it. But what if it gets trickier? The most important point on this graph is the bottom of the V. Does that make sense? Because it's going to have to come up and out from that. So we always need to find the center. So how do you find the center? The center is what makes the absolute value 0. What number would I plug in to make this 0?
7.
7. Do you see how 7 minus 7, that would give me 0 overall? That's going to be my center. So 7 is the center. Because it makes the absolute value 0. for the number that makes what's inside 0. When you graph, you wanna graph the center, and then you wanna see what happens on either side. So on one side of 7 I have 8, and on the other side of 7 I have 6. So let's plug in. 7 minus 7 is 0. Absolute value of 0 is? Perfect. Plug in 8. 8 minus 7 is? Absolute value of 1 is? 6 minus 7.
Negative 1.
Absolute value of negative 1? 1. Alright, let's graph our points. We have a point at 7, 0, 8, 1, and 6, 1. Zoop. Zoop. Do you see how these graphs have line symmetry? Right down the center?
Yeah.
Also, because they have line symmetry, when we plugged in 8, we got out 1, and then we got the same thing when we went to the other side. But that makes sense, right? If they look the same, I should have gotten the same number. So we're gonna take a shortcut next time, and we're not gonna calculate both. We only need to calculate one, and then we can use that answer for both places. I'll show you what I mean if that doesn't make sense. Come down here, look at just your absolute values. What would make it 0? What value of x would zero out what's in there? 0. So my center is at 0 for this one. Alright, what's on either side of 0?
1 and negative 1.
Yeah, and you can pick other numbers if you want to, just remember you're gonna have to graph them. Alright, if I plug in 0, 4 times 0 is 0, the absolute value of 0, still 0. Negative 0, that's not really a thing, so we have 0. 0 minus 1 is negative 1. Alright, let's plug in our positive one. 4 times 1 is? 4. Absolute value of 4 is?
4.
Still 4. Attach the negative. So now I've got negative 4. Negative 4 minus 1 more is?
Negative 5.
Negative 5. And because it has to be the same on both sides, this one also has to be negative 5. So I'm not going to do the process again and plug in negative 1. I can just steal my answer because it has to be the same. Because it has to look the same. Alright, 0, negative 1. There's a point. 1, negative 5. And negative 1, negative 5. Ooh, I didn't do domain and range. We gotta do domain and range for these two. Domain and range. We'll start with this one and then I'll go backtrack to part A because we need it for that one too. Is it gonna expand left and right and hit everything?
Yeah.
Yes. So again, this is gonna be one where they should always be all reals. X such that X exists in the set of reals. So again, when you don't know today, a good guess for the domain is it's reals. Alright, y isn't though. Y such that, what do we notice about y? Yeah, it's less than or equal to what? Negative 1. Like I said, I forgot to do it for part A. Let's go back up to part A and kind of think along those same lines. Domain, is it going to span out and touch everything?
Yeah.
Yeah, x such that x exists in the set of reals. Range. Where does it start?
0.
Yeah, and it goes up from there. So that one would be greater than or equal to 0. So the homework you're going to encounter tonight is either going to be this type of graph, or the piecewise graphs we saw before, or you could see a story problem. Hi. Thank you. Alright, so homework for tonight, we're on assignment number 8. We are on page, you can't see that, 53 to 54. Numbers 1 to 6 and 13 to 15. If you want to grab graph paper, you will need 6 graphs total. There are 3 of each type. So there are 3 of the piecewise embedded in here, and then these are the 3 absolute values. I'm going to put my book on the board.
There's a vessel. Can I use the restroom?
Of course.